Hi, and welcome to my experiment. This was originally intended to be a hands-on hardware hacking workshop, and then I came in here earlier and was like, that's a lot of people. So I decided to up the stakes. And so now I'm going to do a hands-on hardware workshop at the same time as I give a presentation. So if you want to do the hands-on hardware hacking, I wrote out instructions at those cocktail tables over there, and you are welcome to head over there. Please join strangers at tables, become a team, talk to each other quietly while I talk. And hopefully you can figure stuff out and get it going and make something cool in the very short time we have. What's up? It should be hopefully self-explanatory. Meanwhile, I put together some slides which will be similar to what they're doing over there, but in more of a presentation format, so that the rest of you who don't want to get your hands dirty or there just aren't enough Tessels can see what's going on. So thanks for bearing with me. This should be fun. Also, please do interrupt me with questions, raise your hands, and I don't think I have enough slides for 20 minutes because I just wrote them. So I want to talk to you about what I'm here for. So this is the Tessel project. We make hardware. So this is a Tessel 2. Some of you might have been familiar with the Tessel 1, which we started shipping over a year ago. And the whole point of Tessel is to make hardware accessible to people who previously didn't want to release the magic smoke or burn electrical components that cost them time in shipping, and basically make this something that was easier for people. Sort of on the IoT wave of things, mostly along the lines of we were frustrated that it was hard to make stuff. And so we built this board that has Wi-Fi on it and this plug-and-play interaction with different sensors and actuators. I guess I'll show you. And the whole point of this was specifically to design it to be similar to what a web developer will be familiar with. So it runs Node, and when you want to add a capability, you don't just plug it in the side. Note that is no solder required. But this is the NPM module name written right here on the Silk. And that's literally all the hardware you have to do. If you're more into hardware hacking, these are GPIO pins, and you can do whatever you want. There should be SPI, I2C, UART, and GPIO broken out on both of those. If that was gibberish, you are the audience we intended to build for. So I should note that this is an all-volunteer organization. I'm here on my PTO, representing the Tessel project. And we used to be a startup, but earlier this year, around April, we reorganized as a project under open governance. And we were really strongly inspired by Node.js and how well a group of individuals could decide to come together and make a project that wasn't trying to make money, that wasn't trying to, I guess, we were a little frustrated with getting caught up in the business aspects of being a business, and all of us just wanted to be engineers. And so that's what we became under this open governance. So I'm one of the steering committee members, sorry about that. I'm one of the steering committee members in our open governance for Tessel. And if you want to learn more about us, it's on github.com/Tessel/project, and you can see all of our open governance stuff. And that's pretty exciting because we used to be 8 people in it was an office, it was technically a garage, but we literally bought an office for it. Now instead we are this distributed group of people, and there's just some incredible developers that I wouldn't have met otherwise, who decided to join after we decided to not be a company. Somehow it was easier for people to say, yes, I'd like to get involved if no one was getting paid. And so that was something really cool. And we really hope that we can help to have a voice in what open source looks like in the future. And it's particularly open source hardware is, it turns out, pretty hard because you do have physical goods, testing equipment, all of this stuff. If you're curious, just ask me questions later. So enough about the project. Am I picking up both of these mics? Okay. So what is this thing that I'm talking about? So Tessel is a fully open source hardware and software platform that makes it easy and intuitive to develop internet-connected devices. So specifically, looks like this. It fits on a Post-it note. So it looks kind of big to me, but Post-it notes are not so big. It has internet built into it. We took a chip out of router hardware, which let us get Linux and Wi-Fi for relatively cheap. We have MediaTek running OpenWRT, and we have all these pins, which I talked about. In addition, if you're familiar with the Tessel 1, it just had these modules. We also have USB capability, so that literally any like webcam you buy on Amazon or any plug-and-play USB sensor or actuator, like a camera, like Bluetooth, like any of that, you should be able to plug in here and use it. I say this with a caveat because I don't have an example yet, but we'll get there. And then we also have Ethernet, if that's your thing, which is really useful actually for IoT. A lot of people ask, what is it all for? And having been in this space for the last couple of years, there are a lot of silly applications. And I mean, the connected toaster is the canonical silly example of something you don't necessarily need to get connected. But those are really the entry point. They're the things that get people excited because it's the thing they can think about in their own home. But if you go further than that, there's a pretty big proposition to be had in things that would necessitate having an Ethernet port. For example, there's a guy somewhere in the Midwest who owns a machine shop, and he used his Tessel to hooked up a bunch of relay modules to his welding equipment because he didn't want to deal with the various old distributions of Windows that came with those very expensive, never-to-be-replaced machines. Because he wanted to walk up and bring in his iPad one day or whatever laptop he had on him and be able to control his automated welding processes. And he wants to make sure that he can control those at any time. So that's one industrial use case that might necessitate having a wired connection, for example. Or if you wanted to put this on tracking an assembly line, having some kind of heat sensor at different points of the process, it's just one less thing to worry about. I'm happy to do more examples later if you guys are curious. I can probably come up with a lot of different industries. I've seen a lot of different things. So we do host a number of projects on this project site here, and a lot of them are these sort of silly things, like this dog sleep tracker. But it's cute because it shows how you can use a hardware module and Wi-Fi and hook it up. Because it's Node, you can just throw the Twilio API in there, that's fine. All that kind of stuff. You can also see, a basic web server on here, or this guy in the bottom, that must be your left, hooked up his entire house to track his energy monitoring. The basics, and this is what they're all doing over there, and I do recommend if you get a chance to swap out with anyone over there to try this stuff out. It's just Node. So this is our command line interface. That's actually wrong. It should be T2-CLI, but whatever. Updating the firmware is easy. It is T2 update. That's it. And getting online is just another command line call. And part of our philosophy was we looked at, for example, Heroku and how easy it is to deploy something there. And we said, well, why isn't it that easy on hardware? So we made it that way. Should be easy to get lights to blink. Lights to blink are the hello world. So var Tessel means let's get the hardware, and then we're going to put in a set interval the LED index 0, which is this one. We're just going to toggle it every 100. That's the whole thing. And then T2 run blink.js, that's deployment. Then adding capabilities. So this is, I kind of showed you already with this accelerometer here. This is a climate module. So climate, plug it in, install it with the thing written on it. And the APIs should be as high level as what's the temperature? Here's the temperature. So I think that's all the slides I had. Yeah, this is all for them over there. Question? Yeah, that's a good question. So actually, climate in particular is interesting because, and this is where you get into, well, hardware actually is a bit different than software. It actually heats up the climate module from the board. So if you put distancing wires, it helps. Another piece is it's as precise as you need it to be, I guess. So our stock climate module, we didn't get the nicest parts because most people just want a sensor. They want to say, if it's consistently about 10 degrees off, then they can say, okay, well, when it's above the 10 degrees higher than I wanted the maximum to be, you can just set a trigger. So you can do your own software calibrations, but what I'm really getting at is our stock hardware does that, but you can also do, and I'll just show you actually. You can also do kind of anything you want because these are just hardware broken out, and it should be, so like if you need a high precision thermocouple, that's something that you can do. I wonder if I have this open. This is a really weird, sorry, this doesn't look nice on mobile, and for some reason it thinks I am. So you can see the ones we built are this pretty red, but if you wanted, for example, a thermocouple of whatever, whatever degree of precision you wanted, we have one on here somewhere. And so the idea is you should be able to build your own. And if you wanted help with that, we're up and turn the lights on and off to an LED strip. And that's just been sitting there for over a year now. And I just use USB power to a phone charger, and that's super simple. Yeah. Oh, for sure. Yeah. Yeah, that'd be fun. I mean, you also might want to try, if it's inconvenient to use a battery pack, so if it's like drawing a lot of power, and Wi-Fi generally does, so that's a challenge. You might also want to look at, say, Esperino or any of the various other intended to be super low power applications to get the sensor, and then use something else like a Tessel. Tessel, for example, can be an access point. So you could like Bluetooth to it and then have that post to the Wi-Fi. Yeah. Yeah. Yes? That is a good question. Can you say more? Yeah. I have absolutely no experience in that. But if you go on our forums, or actually more accurately on our Slack, there would definitely be somebody there who would know. Thanks. Is stuff working over there with you guys doing the workshop? Okay, good. Yes? Yeah, that's the plan. So I don't know, how many of you had heard of Tessel before today? Okay, so like half, that's cool. So Tessel 2 pre-orders, for those of you who've been following the story, I largely write those emails. it's been a challenge for us to get through hardware certification, and to be thoroughly honest with you, we still haven't completed FCC certification, but we think that it'll pass. We just submitted this morning again, so we're still expecting January. Yeah. We are going through, so that's actually been a really interesting part about not being a company anymore, is that we all have full-time jobs doing other things. And so we can't like man an entire operations line. Beforehand, we already had pretty good automation set up with, we used Celery for pre-orders, which went directly to an API called a Whiplash, which did distribution. And then when it got low, we would ping our manufacturer Seed, and they would make more of them. We've actually gotten Seed to be interested enough to build a lot of them for us and sell it through their own store and manage that distribution channel, which has been super interesting. At the moment, it's not totally transitioned, but in the future, purchases will go through Seed. And then it's actually pretty cool because the foundation, or the way we set it up, the foundation gets a piece of that as a royalty. And so then that feeds back into the Tessel project and to the jQuery Foundation and the Dojo Foundation. That is a good question, and one I don't necessarily know the answer to. I think that that's the sort of thing we come to as it comes, but I think that that'd be something that we would handle within the foundation. Yes?
Do you have the price? You might have the price $35
It's intended to stay 35. I don't know why it would change. It's possible that someday it will. Any more questions? Yeah?
What version of Node are you guys running? Or are they going to change it?
Right now we're on Node 4, 4 point whatever. I think it's 4.0 on the device, but it might not be. And we'll try and keep with Node's plan for long-term support and maybe ambitiously pick up some like 5.0 stuff. Yeah? I don't know the full history about how, so you're asking about how like Wi-Fi has gotten so cheap?
Wi-Fi or the CPU or the memory is just an amazing progression from
Yeah.
chip alone costing 5 times that to similar speeds.
Yeah, it's actually super interesting. I wish I knew more about the details of why internet on hardware has gotten so cheap recently. A big piece of it is this expectation of the Internet of Things. Even in advance of it being widely adopted as a useful thing, people have started just buying and buying internet chips, which just drives the price down. For things like Tessel and Particle and these kinds of things, it's a little bit race to the bottom as well. Like we price ours at 35, and we make very little margin, as you might imagine. Luckily, we're not a company, so that's more okay. But it's really interesting to watch how the economies of scale just completely have been able to change the way that Wi-Fi is distributed. Perfect, thanks. Does anyone else have one more question?
When you see Tessel 3, what is that like? Obviously,
We're iterative. We'd want to make sure and test it out and see what the response is, see where it's failing before we decide on what a next iteration would do. I want to make sure and take, who was that? I saw a hand. Yes. Yes, it is OpenWRT, and I'm not sure what version. Thanks, everyone.